Greetings to every one of you. So in this video we are going to discuss about another important concept from operating systems, that is preemptive priority scheduling algorithm. This is a preemptive method of CPU scheduling algorithm that works based on the assigned value of priority. Higher priority process will be executed first. Actually, preemptive priority, it means stop the execution of current process whose priority is very less. Transfer it from the execution queue to the ready queue and allocate the processor to this newly arrived process with a higher priority, that is more value of priority. So let me explain this algorithm with the help of a problem that is given, in which we have 4 different processes with 4 different priority. So the lowest priority value, it is 5, and the highest priority value is 40. Greater the value, greater the priority. So that is the assumption we made here. With the help of the Gantt chart, we can calculate the completion time of the processes. So at time 0, the first process, that is P1, enters. So with its burst time, it is 6 milliseconds. So initially a very small amount of time quantum will be given for all the processes. So that is in this case, that is 1 millisecond. Okay, so 1 millisecond of time that is given for process 1. So now at time t1, that is 1, the process 1 completed 1 millisecond of its execution. So now its available remaining time, burst time, it is 5 milliseconds. Okay, at the time 1, we have another process that is enters into the ready queue, that is with the higher priority, that is 15. So that is P2, process 2. Its burst time is 5 milliseconds. Okay, so what will happen? Higher priority, that is P2, so automatically P2 will be loaded into the processor, and again it will be executed for another 1 millisecond of time. Okay, so at time 2, this P1 with 5 and P2 completed 1 millisecond of its execution, so it will become 4. Now at the time 2, check that any other process that is arrived. So we got another process, that is P3, arrived with more priority, that is 30. Its burst time, it is 3 milliseconds. So automatically P3 will be the processor will be allocated to the process P3. Okay, then again that will execute it for 1 millisecond of time. So at time 3, that's so it is the new list will be like this: P1 with 5 milliseconds and P2 with 4 milliseconds. So P3 has completed 1 millisecond of its execution. So P3 with 2 milliseconds now. Check at the time 3 any other process that is arrived. No process arrived at the time 3. So automatically, currently that is available process, that is P3 with a higher priority, that will continue the execution for another 1 millisecond of time. Okay, so at 4, so here new list with P1 with 5 millisecond, P2 with 4 millisecond and P3 with 1 millisecond of time. So this is a new ready queue. So now at 4, we have another process that is arrived, that is P4 with 1 milliseconds of burst time with higher priority. So automatically what will happen? The P4 will be given the chance for execution. So P4 which require that is only 1 millisecond of maximum burst time. So with this the P4 it completes its job. So remaining process are P3 with 1 and P2 with 4 millisecond and P1 with 5 milliseconds. Okay, so at 5 P4 it is over. P4 it is completed. So now we have 3 processes. So automatically what will happen, the hierarchy that is given for P3, so automatically the processor allocated for the process P3 with 1 milliseconds of time. So at 6th millisecond process P3 it is over. Now we have only that is 2 processes, that is one is P1 and P2. Okay, so now P2 will get the processor P2 which require 4 milliseconds of time, 4 millisecond at 10, P2 is over. So remaining is the P1 which require 5 milliseconds of time. So at 15th millisecond process 1 is over. So this is how we can prepare this Gantt chart. Okay, so from this now we can get the completion time. So completion time of P1 it is 15 and completion time of P2 it is 10. Completion time of P3 it is 6. Completion time of P4 it is 5. So we can calculate the turnaround time, that is completion time minus arrival time. It is 15 minus 0, that is 15. It is 10 minus 1, it is 9. It is 6 minus 2, it is 4. 5 minus 1, it is 1. Okay, so total is 15. It is 24, 28, 29. So 29 is the total turnaround time. Total turnaround time it is 29. So similarly we can calculate the waiting time. So the waiting time can be calculated as turnaround time minus burst time. So 15 minus 6 it is 9. Okay, 9 minus 4 it is 9 minus 5 it is 4. 4 minus 3 it is 1. 1 minus 1 it is 0. We can calculate the response time, but what will happen as soon as the process that is enters, so immediately all the processors get responded. See, for example, the response time can be calculated as the starting time of the process minus the arrival time. 0 minus 0 it is 0. Similarly, P2 started, the starting time for P2 it is 1. 1 minus 1 it is 0. Similarly for P3 it is 2. 2 minus 2 it is 0. For P4 it is 4. 4 minus 4 it is 0. So that means response time is 0. It means immediately the process responded by the processor. That is the meaning. Okay. So now we can calculate the average turnaround time. So average turnaround time can be calculated as it is total time. So average turnaround time is equal to 29 divided by 4. That is we have 4 processes. So the total turnaround time divided by the number of processes, so which is equal to, that is 7.25 milliseconds. Similarly, the waiting time we can calculate, that is it is 14. Average waiting time is equal to 14 divided by 4, which is nothing but 3.5 milliseconds. So I explained what is this preemptive scheduling algorithm, and what is this preemptive priority that I explained. With the help of a given problem, using the Gantt chart, we calculated this completion time, and also we calculated the average turnaround time and average waiting time. I hope you understood the concept, you understood this algorithm very well. Most of the examination, the gate examination as well as net select examination, this kind of problems they are asking. Thank you for watching. Bye.